All right. In this video, I'm going to introduce client-server communication over a network. Although in this case, the network is just going to be one computer. I'm going to have this computer communicate with herself. And in a follow-up video, I'm going to show how to integrate what we learned last week about multi-threading into a server application environment. Now, to start out, in order to get a good grasp about what we're going to do here, if you're not already familiar with the term or the idea of client-server networks, you'll want to get familiar with that either through reading in the textbooks or reading online. But basically what we're talking about is two different kinds of programs. A client program, which requests information from some remote system, and the server application that fulfills that request. The most common pair of client-server applications that we work with on a day-to-day basis are, of course, the web browser on our computer acting as a client for web servers out on the internet. So in that form of client-server communication, our web browser, Chrome, Internet Explorer, Safari, whatever, is submitting requests across the internet to a web server. And the web server's job is to generate the HTML web pages and send them back to our web browser for viewing. So we're going to build a very simple client-server system here. Let me start a new project. All this system is going to do is our client program is going to send some text to our server program, and our server program is just going to send that same text right back to the client program. So just a very simple back and forth. What's commonly referred to as an echo. You type something in and it gets echoed back to you. So we'll call this echo demo. And I will not automatically create a main class here. I want to actually create two separate main classes for this project. We're going to need, in essence, two separate programs, a client program and a server program, which means inside of our project, we're going to end up having two separate main methods. So let me start with, it's actually a little bit easier to start with planning out the server side. So I'm going to call this server app. And give it a main method. All right. So what our server application needs in order to fulfill its role, it needs to, first of all, it needs to request from our computer's operating system the ability to accept network connections. By default, computers, modern computer security involves the operating system having really tight controls over what programs on your computer can receive connections from the network or the internet. Now in Java, to open up the computer to the network for connections, you have to create what's called a server socket object. And the server socket object needs to know which port on the computer it should receive external connections from. Now, a port on a computer in terms of network connectivity is basically like, well, having multiple mailboxes in an apartment complex. If you want to send a letter to a person living in an apartment complex and you only have that complex street address, and say that apartment has 200, that building has 200 apartments in it, it's not going to find the right place. So the port number is basically the apartment number for this program on your computer. When another computer wants to send a request to your server program running on a computer, it needs to know which port your server program will be accepting connections on. So let's go with 1, 2, 3, 4, 5. this. And because the server socket is dependent upon, oops, didn't mean to jump back there. The server socket is dependent upon receiving permission from the operating system. It's possible that there could be some kind of interruption or exception going on here. So we're going to need to surround this with a try-catch. Okay. Okay, now as soon as we start that server socket, our computer is able to receive connections. But those connections are just going to build up until we actually do something with them. The server socket's accept method receives basically the first connection in the queue of connections coming into this particular port. Again, port 1, 2, 3, 4, 5. Not caring about any other ports listening on the same computer. So the first connection coming into port 1, 2, 3, 4, 5 will be accepted and converted into just a regular socket object. And socket objects are what the computer uses for just basic back and forth communication. Right. Now with the server socket object, we can open up two-way communications with the other application connected to the server. And if you did the reading in chapter 19, basically anytime Java wants to communicate with an external system, you're usually going to be dealing with input streams and output streams. And in particular, in this case, since we're going to be sending strings back and forth, we would like a data input stream to receive data. I'll assign these in a second. And a data output stream to send data back. All right, so this data input stream is going to be wrapped around the basic input stream that we get from our socket. Okay, so this our socket is going to provide us with access to input from the program on the other ends of this connection, and we're going to wrap that with a data input stream so that we can convert that incoming data into string objects, or other primitive data type objects that the data input stream supports. Similarly, when we are sending data back to the program on the other side of the connection, we need a data output stream, which is wrapped around the output stream for the socket. So these two objects right here are what are going to enable this two-way communication. All right, now this is where we kind of need to establish the sequence of events that's going to happen once the client program connects to the server program. Basically, the server program and the client program need to have a common understanding of what's going to happen once the connection is established. And this is often referred to as a protocol. All right, so for example, in the web, we have the HTTP, the Hypertext Transfer Protocol, which is a sequence of steps that client applications and server applitions basically understands that things need to happen in a certain order, a certain sequence for data transfer over the web to work. Well, our program needs the exact same thing. We need a protocol. We need to know what's going to happen on both sides of the communication. What is the client going to provide, and how is the server going to respond? So I'm going to assume kind of a step one here, that the client program sends a name string to the server. So whatever user is on the client side here running the client program is going to type in their name, and that's going to get sent to the server. So that's because that's coming from the client to the server, that's going to come across our data input stream. using the read UTF method. All right, now once we receive that name, for the sake of debugging here, we're going to print it out. We're also going to send a confirmation back to the client that they connected successfully. So using our data output stream, we're going to write a string back. So that's step 2 of our protocol. All right. And step 3 is that the client is just going to start sending us messages to echo back to it. All right, so client will send a message, server will echo it back. All right, and the client's going to be able to do this any number of times. So we're going to kick this whole thing into a do-while loop. We'll have some kind of input string here, and we will do while not input equals nor case exit. All right, so we're going to do step 3 over and over again until the client sends us the message exit. So used to using scanner, but we want our data input stream. We're going to read our message from the client. And then we're going to write back to the client. Name says there we go. We're going to make it look, more or less like a chat message. Oh, I missed something up here. IO exception. Uh-oh. I did something with my brackets here. There we go. Found that one. There's nothing more embarrassing than a missing semicolon or bracket that you just can't find. All right, and then eventually we'll put this after the loop. Eventually, step 4 in our protocol, client will have sent exit message. So our loop will have terminated, and we'll want to close the socket. So this is the server side. Now, it's important to understand the steps of these protocols from both sides of the equation. So let's go over and build our client app now. Also need the main method. They both need to be running in order for this to work. And I'm just going to copy over here as an outline steps of the protocol so we don't miss anything. Now, unlike the server application, the client application does not need to build a server socket and listen on a port. It's the job of the client application to connect directly to the server. And the client can do that just by building a socket object and attempting to connect to that port by providing that port number as the parameter. This, of course, will require a try-catch as well. Doesn't seem, oh, sorry, I forgot one other crucial piece of building a socket object, all right? In order to establish a connection, you need to give the host name or the IP address of the computer that you want to connect with. And this is a string. And I'm going to use the special host name called localhost, which basically means to connect to this computer. You can also use either an IPv4 or an IPv6 IP address, something like that. Or something like, I don't know, any other kind of host name, as long as you know that that host name is going to accept your connection on this port. Probably if we try to connect to google.com on port 12345, nothing's going to happen. All right, but again, localhost is a special host name that states that we are trying to connect to this very same computer. But if you have multiple computers at home, you'll want to test this out running your server app on one computer and your client app connecting to that computer, possibly by IP address. Okay. Now we're going to get our try-catch block. All right. On this side of the equation, we will also need a data input stream and a data output stream. All right, now that we've established that connection, let's get into our protocol here. The client program needs to send the name of the user to the server. All right, so in order to do that, to get the person using the client program to enter in a name, we're obviously going to need a scanner for our system input. And we're going to want to prompt them. Okay. And then we can just go ahead and send that data. All right. So again, this is the mirror of what's going on the server side. All right. On the server side, the first thing that the server does as part of the protocol is it uses its data input stream to read a string from the client. That means the client, the first part of the client's protocol, has to be writing that string to its output stream. So the client's output stream is connected to the server's input stream and vice versa. Now that means that the next step, step 2, the server is writing to its output stream, which means that the client is going to be reading from its input stream. And we're just going to go ahead and print it out. That's just the confirmation message. All right, wrong hotkey there. All right. So this is where we're going to kick into our loop, because on the server side, got this do while going on. So we're more or less going to be doing the same thing here. except in this case, we're going to be getting our input from the scanner. Right? We're going to read in the client's message from the scanner, okay? And then we need to write that to the server. All right? And then the server is going to echo it back. All right, and then if it was exit, we'll terminate that loop. And then we can close the socket from the client side as well. This could actually throw us a little error on either side of the equation. We're going to end up in kind of a race here to see which one closes the socket first. So we could do something like if it's not already closed, then close it. Right, something like that. And we should probably do that on the server side as well. That should save us some errors, because if the server closes the socket first, then when the client goes to close it, it'll kick an exception. All right, let's test this thing out. As usual, I provide no assurance that I got it perfectly right on my first time through, but let's give it a shot. Now, testing this is going to be kind of unique, kind of interesting. We're actually going to have two programs running through NetBeans at the same time. If you come over here and look in the project view, you can see that both of these .java files have the little green arrow on them, which means they're both runnable. And if I try to run this project, it's going to ask me which one do I actually want to run, which one do I want to have as the main class. And they're both equally important. They both need to be running. The server actually needs to be running first. If we try to run the client without the server running, then the client is going to try to connect to port 12345 on localhost, and it's going to fail immediately. So that's no good. So in order to select these individually for running, I'm going to start with the server app, right-click, and just go to Run File. Okay, so our server is running and awaiting connections, and we're going to have to pay attention here to the fact that there will be multiple output windows, and we're going to have to jump back and forth between the two of them. And unfortunately, in NetBeans, there's no way to split out the output windows and kind of have them going side by side. So I'm just going to have to toggle back and forth. And if you want to see what's going on, I welcome you to download my sample code and run both of them yourself. All right, so now that the server is running and awaiting connections, I can right-click on the client app.java and do Run File. Okay. So now in our output window, we're seeing the client side. Again, there's no great way to tell because they both say Echo Demo in the title. All right, but we can see that this is the server. Server is running and waiting connections, and this one's asking us for our name, so we'll type that in. All right, and this is telling us that we've successfully connected the server. Great, on our client side. Over on the server side, we can see that it printed out Zach is connected to the server. Perfect. We're actually not going to see anything else on the server side. The server doesn't have any other input or output, rather, to the console, its own console, other than just that a person is connected. Everything else the server does is just echoing back to the client program. So if I type in hello, it echoes back. Zach says hello, but that was sent back through the socket, right? That wasn't printed out on the server side using system.out. There's nothing else here on the server's console. Okay. And then finally, we type exit from the client side. Yeah, Zach says exit, and we can see that both the loops on both ends have now terminated. All right, so that's just a really simple client-server program just to get the basic mechanics down of how do you connect, use the input streams and output streams. The next video after this, we're going to go a little bit deeper, and we're going to integrate some of the multi-threading techniques that we picked up from the previous chapter. So we're actually going to build a server application that can handle requests from multiple clients at the same time. Thanks for watching.